So today I want to talk about how we compare means across different groups. And first, I want to get into what are we really talking about here. So when we do statistical analysis in IO psychology, we're typically taking two approaches. Either we're looking for associations or relationships, or we're looking for differences. When we're looking for relationships, what we typically are looking for is two, maybe more variables in a single sample, right? So two variables in a single sample. And what we're interested in is there a relationship between the variances in of those variables in that one sample? So we take one variable, we see that for each person, they deviate from the mean in some way, right? So there's an average for the variable, the mean for the variable, and each person deviates from the mean in some way. And then on some second variable, they also deviate. There's some variance from the mean as well. And we're looking to see if there's a relationship in the way they vary, right? So are they both, oh, for one person, does the fact that they're higher on one variable mean they're also going to be higher than the other variable, or lower, right, for a positive relationship, or the opposite for a negative or inverse relationship, right? And this is the essence of correlation and regression analysis and others, the idea of an association between two variables in one sample. When we're looking at means, what we're looking for is differences in one variable across two samples. So it's a little bit different approach. What we want to see is, are the means different across of this one variable across these different samples or groups? So we use t-tests and ANOVA are the classic ways of doing this. There are others as well. But that's really what we're doing here. So the first thing is to understand these two different approaches towards what we're trying to accomplish. But today we're talking about this means testing. Look at the means of a particular variable and how it differs across two different groups. We're interested in, is there a difference between these two groups on this variable? And we take a difference in means to be indicative of a difference between these groups. So I'm interested in, is there a difference between my group and a larger population, right? So is my group somehow different from a certain larger population, right? So are the employees at a particular bank branch different from all of the other employees at the bank? Maybe because they've gotten training, or maybe because they have a different leader, or there's some group level variable that makes them different from the rest of the population. I might be comparing across two different groups. For instance, an experiment, a group that received a treatment and a group that did not receive a treatment. I might be looking at a group over time, right? Before training and after training. That would be another thing. And is there some significant difference in the means on their abilities before training and after training? This is why I want to compare these means across groups. I do this with experiments for example. Again, the training example, I conduct training, some sort of treatment, and I see if there's a difference afterwards. Sometimes I just want to see if there's a difference among groups based on demographic makeup, maybe gender, race, age, tenure, etc. Again, maybe just different groups based on group level variables. Do they work at different branches? Do they have different leaders? Did they receive different training, right? And just these between group comparisons that are different on some sort of other variable. So what do we infer from these differences between groups? And really what we're trying to find out is are our samples from different populations? In the training example, when a group receives training, they are now part of a population that has received training, as opposed to a population of people who have not received training. And we want to see if there's a difference in these two populations. Are they actually a different population, or are they the same population? The null hypothesis when we're looking at differences between groups is that everybody is from the same population, that any differences among our samples is just sampling error. It's just by chance. It's just something else going on. It's not a systematic difference that is indicative of a difference between populations. So our null hypothesis that there's from the same population is that the means of this variable are the same in our two samples, or the same in these two populations. The alternative hypothesis, of course, is that they are not the same, that they are in fact different. So how would we look at this? What's an applied example of this? I might do some research question about a transformational leadership theory, right? And so in general, if you've learned a little bit about leadership, you've heard about transformational leadership theory, the idea that certain leaders have behaviors that are very inspirational and tend to inspire people through inspirational appeals, through idealized influence, through individual consideration, through intellectual stimulation, that these leaders really inspire people, as compared to the typical opposite approach here is we typically look at what we call transactional leadership, right? And here's leaders who use incentives and rewards rather than inspiration in order to achieve their goals. And look, I'm really simplifying transformational leadership theory. There's a lot more to it, but that's kind of the broad strokes. And so what I might do is I might ask a question of, well, do employees of transformation leaders have higher performance ratings? Do they perform better than employees of transactional leaders? So in this case, I have an IV and a DV, right? An independent variable and a dependent variable. And typically my independent variable here are the groups. These are the differences among groups, right? So in this case, it's a group with transactional leader versus a group with a transformational leader. My IV, when I'm doing means testing, is about what separates these groups from one another. Then the DV is that continuous variable here that I'm trying to predict this difference, right? So in this case, the performance ratings. Now, if you look at this chart, maybe we've done some research and we've looked at performance ratings across two groups. In group one, for whatever reason, we decided their leaders were more transactional. Group two, their leaders were more transformational. And in group one, we found the mean performance rating was 6.12. And for group two, with the transformational leaders, their mean performance rating was 8.15. Well, certainly, I actually graduated from first grade. I know that there is a difference between 6.12 and 8.15. I know that they are not the same number. The question is not, are they different numbers? The question is, are they statistically significantly different numbers? Is that difference, right? So it looks like about, 2.03? Is that difference indicative of a true difference between these groups, a systematic difference between these two groups, or is it just chance, right? My sample size here, 52 people total, 26 in each group, fairly, not the tiniest sample ever, but a small enough sample that I might say, that 2.03 might just be due to error. And so the question I'm going to ask is this more than I would expect from error alone, right? Is this more than what we would expect? We would expect some sort of difference, right? So what if I'd had 6.12 and 6.13? Then I'd say, well, that difference is probably not enough to be real, right? It's not enough to be significant. On the other hand, if it was 6.12 and 100, especially on the 0 to 10 scale, I would say, well, yes, that's a huge difference. It's very important. But 6.12 and 8.15, I don't know, just by looking at the numbers, is that a significant difference? And the way I determine if it's significant is I compare it to the error that I would expect. If it's bigger than the error that I would expect, if that difference between the means is bigger than the error I would expect, then I say, well, there's something going on besides just that expected error, that standard error. On the other hand, if it's the same size or smaller, then I say, well, this is what I would normally expect. So I'm not sure I'm really getting there. Now, I do want to do a quick note on hypothesis testing. So in our research question here, we're saying we actually suggest here a directional hypothesis. We're suggesting that transformational leaders have higher performance ratings compared to employees of transactional leaders. When first of all, our theory should always drive our research. We should not, in general, take an exploratory approach. We should have a theoretical approach. This is important because our probability and statistics is based on the idea of conditional probabilities. It's based on the idea that we are making predictions and we're based on theory and we're testing whether those predictions come true. If we're just being exploratory, then we're capitalizing on chance and we can't really say that any difference was due to anything other than chance. But if we want to make a systemic difference, we have to say that this is something different from chance, which means that we have to make a prediction. The example here is playing the lottery. I can predict yesterday's lottery numbers all day long, right? And I might even come up with all kinds of, in hindsight, good reasons why the lottery numbers came up the way they did yesterday. The question is, can I predict tomorrow's lottery numbers? That's how I prove my theories, right? And so we have some a priori idea here. And in our a priori theory, we should provide direction. We should say if it's going to be higher or lower. There are some who suggest that not only should we provide direction, but we should say how much higher and how much lower. I'm not really ready to go that far, but there are certainly a camp of folks who think that that's the way we should be doing it. But at the very least, it shouldn't just be, is there a difference or isn't there a difference? Right? Because what if it had come up that transactional leaders actually, or employees of transactional leaders actually had higher performance ratings than employees of transformational leaders? Well, then I might be able to say, well, see, I told you it'd be different, but that was not my theory. My theory was that it would be higher. So don't chicken out. Make theory that that is directional, that suggests something more than just no change. It actually suggests a direction of that change. Now, having said that in a theory sense, the answer is a little bit different in a statistical sense. So if we look at the chart on the left here, what I have is two z distributions, two normal distributions. And what we see here is that at the 0.05 level of significance, it actually takes a more extreme test statistic to achieve statistical significance with a two-tailed test. So if we look at the one-tailed test, in order to say there's a statistically significant difference, in the one-tailed test, at the 0.05 level of probability, my z needs to be 1.65. However, for my two-tailed test, that z needs to be 1.96. It is more extreme. It's a more stringent test. We say it's a more conservative test. So the problem is if I'm always making these directional hypotheses, a directional hypothesis traditionally is tested via a one-tailed test. However, the one-tailed test is a little more lenient statistically. So in order to be more conservative, in order to side on the side of caution, we say use a two-tailed test as a matter of course. So in your undergraduate or even high school statistics course, you may have always learned have your hypothesis, the direction of your hypothesis, whether it's non-directional or directional, drives whether you do a one-tailed or two-tailed test. What I'm telling you is a little more nuanced. One, you should always have a directional hypothesis because that is a more conservative, practical, theoretical approach. And you should typically test that, unless you have a good, strong reason not to, you should typically test that using a two-tailed test because that is the more statistically conservative approach, and you can be more sure that your results are important and useful rather than taking the more lenient approach. So I know that's a little bit of a nuanced difference, but that's generally best practice in IO psychology, to have the directional, research-driven, theoretically driven hypothesis tested via a two-tailed test.